Okay, we're back with Andy Lentz here in Bothell, Washington, with some variations on his cookers. Tell us what you got here, Andy.
Okay, last winter I built another cooker. It's a reflector oven. It's a reflector, and then I have a cover on it that retains the heat. So it's sort of a reflector oven, I guess. And I used it. The dish is a purchased item from Amazon. It's a 28-inch, what's called a beauty dish.
Yeah.
It's used in photography as a light source, a reflective light. In the center of it, there's a hole in it. There's usually a lamp put in it, and that provides the light source. And then the interior, it was like white anodized, clear anodized to give it a light reflected source. And the focal point, I measured the focal point on this is between 4 and 8 inches from the bottom, 8 inches from the bottom, which is perfect because I don't want a single spot. If there's a single spot for the focal point, it's going to get real hot and start to burn. And to find out where does the sunlight, when the sunlight hits the oven, where will the light be reflected? And I'm using a pointer, which is an LED pointer. I added a block so it's perpendicular to whatever surface I put it on. And I'm using a LED. If you want to use something like this, don't use a laser, because if you have a chance of, if you get the laser in your eye, that's not good. It's bad. But this is LED. It's harmless. So if I turn it on, and this is the sunlight coming in.
Oh yeah. It was on there. Wait, yeah, there we go.
See, it's under the dish now.
Mm-hmm.
Here it's on the side. But this little tool gives you an idea where the sunlight that you're going to be using, where when it hits your cooker, where's the light going to bounce to, and it's very helpful. I added a polycarbonate cover to it because when I tested it without the cover, I got a certain temperature. And then I thought, well, if I put a cover on it, it'll become like a little oven. And with a cover, I increased the temperature about 50 degrees Fahrenheit.
Sure.
Now, since this now was an oven, the dish is metal, and I was warming up the back of the dish. So I was losing heat in the oven in the back. And so to retain the heat in the cooker oven, I added insulation, which is like this is like half-inch foam, and the back of it is all covered with foam. And by doing this, I also now increased the temperature in the whatever I'm measuring my temperature inside by about 30 degrees. So I'm not losing temperature out the back. This got a little warm, but so what? Now, when I do my cooking, I always start out by measuring what the intensity of the sun is, and this is a meter that measures the sun in lux. I'm not going to give you an explanation of what the lux is, but on a clear sunny day in the summer, this reads like 130 K. And if it gets cloudy, it'll go down to less than 100 K. And if it's less than 100 K, I don't make any attempts to cook. The sun's not bright enough. But by putting the cover on here, I am blocking some of the sunlight that is getting to the reflector. I'm blocking about 10, 15 K. But I gain more in temperature with a cover than I lose by blocking the sun. So it's a kind of a win-win.
Sure.
Okay. I bake, only cooking I do is I bake bread or I bake dessert cakes. And this summer I sort of concentrated on blackberry chocolate chip, something that was a cake. And we have blackberries growing out the back, and they had a lot of blackberries, and so I saved them all, and I baked several cakes, very tasty. And it took an hour and a half to bake in this pot. This pot is a cast iron, and cast iron will cook better than if you use a pot with just the thin metal. It heats up slower, but it retains the heat, and you can heat it more than the thin metal pots, like the blue enamel pots. And also the pot that I'm using here, it has to fit in here. It can't be larger. And this is 1.5 quarts, which is big enough for whatever we're going to be eating or using. And my cooking has to be done between the hours of 12 and 3 because I have trees in the back, and the trees block the sunlight, and if the sun is blocked by the trees, there's not enough sun getting to the reflector to do any heating. Okay. This one, it takes 45 minutes to boil water, and that's better than all the other ones I had built. And I wanted to know what happens after the water boils. How hot will it get? And I began using oil, which is canola oil. It's cheap oil, canola oil, and it's harmless. You can't poison yourself or anything like that. And with canola oil, I got the oil up to 350 degrees Fahrenheit, and I think it was maybe hour and a half to get to 350, and it peaked out at 350. And canola oil is safe to use. It'll start to smoke at about 400 Fahrenheit, and the flash point is 600 or 700. Its flash point is 700 degrees Fahrenheit, and which I don't think mine will ever reach.
You have to double what you
It'll never reach 700, but
yeah.
This is just so that it can't. If you use a high intensity, you have a high temperature capable cooker, and if you go past the 700 oil, it'll catch on fire. Now, in measuring the temperature of what I'm cooking, I'm using, this is a cordless thermometer. I put this probe into the pot, and this is outside here, and I can watch the temperature on this as it's heating up. I see on the internet a lot of people use one of these, this is a thermometer for the oven, but with this kind of a measurement, you're only measuring the temperature of the air in your cooker. But what you really want to do is measure the actual food that you're cooking. And having a probe like this it gives you a truer reading of what your food actually temperature's at. If you're doing like meats or chicken, it's very important that you exceed, I think, 160 degrees Fahrenheit for meat. And this will tell you if it's 160 or plus. All this will tell you is what the temperature of the air. If you have a box cooker, you're just measuring the air temperature.
Well, if I may interject too, my experience with those, because I just started off getting cookers and putting in from Target or wherever, getting these thermometers, and I'll put the same brand, three side by side, almost the exact same spot, and they'll be off by 25, 30, 40 degrees, because these are not made for precision.
No.
This is gonna, the
No.
thermocoupler is gonna get you
But they're
precise.
cheap. They're
Yeah.
$5-10.
Yep.
And this is Amazon. This is like maybe $25-30.
Sure.
And if you really want to identify your temperatures, this is much better. Then last thing I use is when I'm building something new and I want to find out where am I losing temperature. If like the back of it starts warming up, this is infrared. I can read the temperature. Now, I can't read the temperature on the pot here because the dots are going through the through the Lexan, and so it's giving me it'll be giving me the temperature on the Lexan. So this would not be correct. But if I want to measure the back of it, if I'm losing any heat here, this does a good job. And these again are $30, $40.
Sure.
Now, if you, this is for people that build their own cookers, and if you want to see if you're improving on your design, make changes, small changes at a time, and keep your variables. The variables are the intensity of the sun, your ambient temperature, because ambient temperature will affect what happens inside here because of this surface is exposed to ambient. If you're doing this at like, let's say 50 degrees Fahrenheit outside in the winter or fall or whatever, versus summer, if your ambient temperature is 90, it'll make a difference on what happens inside. By how much, I don't know really how much, but but if you're doing tests, try to keep your ambient temperature the same. The sun, maybe do it the same time of the day, and the volume that you're testing, liquid, best would be liquid. And if you're using 1 quart or half a quart, repeat the same volume, and then the only variable you'll have in your design is what changes you made to it. And that'll tell you if the changes you made to it improved upon it or made it worse. My goal was always get a higher temperature, and higher temperature means shorter cooking time. And also, like I said to Luther, that my window for cooking here, I live in Seattle area, is 5 months from April to August, and because that's the warm period living here. And also, it's important to measure the sun, the sun to the horizon. If it goes below 45 or 50 degrees, it'll affect the cooker, because the lower the sun goes, the more haze it has to go through. So this was built a long time ago, a kind of a tool I use, and I put this outside and I can see where the sun is in terms of the shadow it casts from the nail. And if it gets to like 45, 50 degrees, I know I can cook. And the angle of the sun here, living here, I did another one on the back here, is I start at 45 degrees, and the maximum it reaches in this area is 65. Now, if you're living more south of, everyone lives more south of Seattle, and this number will be higher. The more perpendicular the sun is, well, you can change this so it's perpendicular, but it has less haze to go through, and the lux may be higher. And
It's 65 degrees. That's in like June 21st, like the
yeah, it's
middle of
May May through July.
Mm-hmm.
Yeah,
Okay.
yeah, and then the sun will starts going down.
Yeah.
I didn't mention that the interior of the dish is covered with this vinyl, reflective vinyl. This works very well. It comes in a roll, and I cut it into strips and then just put them down. And the surface doesn't appear to be perfect, but I think it's good enough. If it gives me 350 degrees, I'm happy.
Oh, yeah.
And so it works very well. That's about it.
Sure. No, that's a whole lot of information.
Yeah. Also, it uses this stand is a design that I've been using on other cookers that have reflectors, and it's also rotates the stand. It's like a sun tracker. It'll rotate. It'll follow the sun. The vertical, to get the vertical adjustment, you need to manually adjust it. But in an hour and a half cooking cycle, I adjust it maybe 2 times. So I can usually just set it up and go away, and I can watch inside the house. I can watch what's happening in terms of the temperature, and then an hour and a half later, come out, and whatever I'm cooking usually is baking. And I don't do any cooking like for dinner because I have to stop at around 4 o'clock and don't eat dinner at 4 o'clock. And so I enjoy baking the desserts.
There you go.
Yeah.
Do you use a hay basket to take it out when it's cooked but still hot, and it keeps it hot through dinner time, or
No.
no?
So
Yeah. But that would be, obviously, that's an add-on a lot of people
yeah,
would have.
you could.
Yeah.
You could.
And it's the solar panel here that
Yeah, the panel, there's a little cast like, show you maybe, like the sun will be here.
Mm-hmm.
It'll go under, and that means that it'll start to rotate. Then as it rotates, this will block the little solar panel, and there isn't enough voltage to the motor to turn it, so it stops. And I think maybe it rotates like every 15 minutes. And this up here is I guess call it the sun finder, because there's a lot of people starting to use this design using a screw with a big head, and then you cast a shadow on the surface, and it's very easy to see, and it'll move, rotate, and then it'll sort of stop when the shadow is in the center of the screw here, bolt.
And all you need to see is the shadow. If it's of the length of the bolt, you know you got.
Yeah. Well,
this
is.
Yeah, we're in artificial conditions here.
It's like.
Oh, they're right there.
Yeah.
But you can make out that. Yeah. Yeah. Yeah, and the insulation, is there a rating to that particular one? Like how hot?
It probably is, but before I added this, the temperature I measured out back here was 130.
Oh, okay.
140 degrees Fahrenheit, which is uncomfortable. You can touch it, you'll feel it warm, but it's not gonna. It'll be uncomfortable if you keep your hand on it for like a half an hour, but it's not hot enough to damage this or burn this. Yeah.
Is that meant for like insulating ductwork for furnaces?
It's for ductwork. It's for industrial use, ductwork.
Yeah.
And I think it comes. You can get like 1/4 inch or 1/2 inch, and
Sure.
so.
And it being flexible, it's like there's There's
Yeah.
the rigid stuff that would be maybe higher R value and everything, but boy, this one you can custom
I
fit.
cut this up in pie shapes, then I put it on the back,
Mhm.
and then used the aluminum reflective tape that does a real good job of making things stay down. And yeah, it's like little pie shapes here.
Sure. So you're just following the curve of the bowl.
Yeah.
Yeah. Nice and snug. So and then when you ran the infrared thermometer, did you find any gaps? That you
Yeah, I still picked up heat,
Okay.
like the ambient was say 885. I was getting like 110. I was still pushing heat through the insulation, which means that I asked, do I put another layer of this on it to capture that, or retain that additional 20 degrees that's going through, or just leave it like it is? I'm just going to leave it like it is.
Sure.
Yeah, because I'm getting my temperature, and I'm happy, and it's also not big. It's easy to carry, and if you build there are a lot of reflectors that are built. They're really big. They're powerful, except if you live in a windy area, the wind is going to catch the reflector and push it over, but if you don't live in a windy area, then it's not a problem. Yeah. This one has a focal point inside. It can never heat anything up here, or if it gets tipped over.
Sure.
And so it's safe in terms of being left alone.
Yep. Well, remind us again, what was the original dish?
This is called a beauty dish.
Okay.
On Amazon, and it's for photography, and it's for getting these special reflectors and for photography or giving special light, and but I was just interested in the shape of it, and when I found it on the Amazon, I printed the pictures that showed it in from a kind of a profile from a shot, and then I just enlarged it, and then I got my shape on it, and then I started to do the lines down onto the reflector side and see where the light will reflect. And it was all reflected inside within 4 to 8 inches. And I thought, great.
Yes.
Yeah.
So what they call the deep parabola, or the focal. I like to start calling it the focal cone, because it really is a cone that kind of starts at one point. This
again does not have a single point, and it's actually someone on Facebook, not on Facebook, but on the website suggested that it's better that it's not a single point. The single point would really burn.
Yeah.
And so that suggestion was good.
Yeah. I found that with our SK14, it's got a little tray that you put the pot on. And I might have a pot this wide, 3-4 inches of stew. And if there are solids, the focal point is maybe like a 3-inch diameter. Well, it'll actually char the solids there if they settle right.
Yeah.
And so I actually have that on the side for other stuff. I'm just going to boil water, it doesn't matter. But I have one that puts another 1.5 inches down, and then it's like almost an even rolling boil across the top. Whatever I do, I never get the charring anymore. So so spreading it out, unless you're doing really caramelizing, frying stuff where you want that real char edge to it, how often do you really need that high heat? So, yeah,
the dish is, I think, like $90.
Okay.
And so,
yeah. And you lined it with this reflective material, or was that part of the beauty dish in there?
No, those lines are overlapping.
Mm-hmm.
This overlaps.
Sure. And you applied that to it. It didn't come with it. Yeah.
If I was going to do it again, I would not do it like across like this. I would make little pie shapes.
Oh, sure.
I think I would get better reflection.
Mm-hmm.
And the question is, do I tear this out and replace it with little pie shapes to gain maybe another 10-15 degrees? No.
No, this in the, I mean, your overlap, it's not like they're crinkling up and
No,
sending
it's
light back out.
been in the garage where the temperature gets down to, in the winter it gets down to the 40 degrees, 45, and summer it's 90 in the garage.
Yeah.
So it handles the temperature okay.
Yeah. Okay, well, I think this combined with our last visit, I mean, it's a tutorial for people who want to make their own cooker, tools to test it with.
Yes.
You know, choose your parameters, figure out what you want.
Yeah.
And I'm glad you mentioned that about the oil, because I'm like that. My panel cookers bring things up to boil, because a lot of stuff I just want to boil all day. But yeah, if I want to bake something, and I'm in Minnesota, not much different from here. You know, we might have a cloud roll over now and again, or I got an hour and a half and a half hour to go, and then full clouds roll in.
Yeah.
So I want to make every use of that last bit of sunlight before it goes away.
If someone wants to start out building a new one, pick the cooking pot you're going to use. You know, and don't try to go, you know, like 4 quarts or a gallon or something that is big.
Mm-hmm.
And then also you have to figure out how to hold it up.
Yeah.
Also, that as the sun moves, does your focal point follow the pot, or does it walk off the pot and it just starts to cool off?
Yeah. And this is a good sturdy. Well, you've got it bolted onto the pot. I just noticed that.
Yeah.
Were those?
This stuff gets hot.
Mm-hmm.
If I take it off, I use gloves.
Sure.
And I don't want anything to be wiggly and slip out of my hand, because it'll burn me.
Oh yeah, no question.
Yeah.
And so the pot, did you actually drill the holes there?
No, they were there.
Oh wow, okay.
Yeah, they were there.
Very handy.
This is again, this came out of Amazon. This is like 12 years old maybe, and I just painted it black on the outside.
Yeah. Sounds like a crusette or something, an enameled pot.
It's enameled. Cast iron enameled. It's called a Dutch oven.
Sure.
Yeah. But select the pot size you want to use, and then build around it.
Yeah.
And again, the bigger your reflector is, the hotter you'll get your pot to heat up faster. But then the trade-off is, you know, you got this big reflector, handling it afterwards, mounting it, the wind, how to manage it, that can become another problem.
Yeah. Well, those are all factors, and I mentioned earlier there's a group of makers that want to come up with criteria for people that want to know just how do cookers perform. If they're going to buy one, you know, they want to make sure their money's well spent.
I think there's a formula in terms of, if you want the energy you get out of the sun can be converted, I think, into watts. Mm-hmm. If you want 1,000 watt capacity, your reflector has to be such and such a diameter.
Mm-hmm. Yeah.
And
yeah, and that might be representative that maybe have a half a dozen that have gone through the PEP test through SCI, of course, SCI, and they list the watts from the PEP test. And they can look at the cooker and say, well, that's how big the reflection area is, or reception area, and take it from there.
Yeah. And then again, whatever you build, make it sturdy so that you don't want it falling over, and whatever you're cooking, the pot is inside, items are very hot, and you don't want that to fall on you.
No.
Yeah, just make it sturdy.
This is a full size, and you can lift this off.
This just.
Oh yeah, and just set it aside. Get the pot, whatever. Maybe the lid can come out.
This is polycarbonate. It's good for, I think, like 500 or 600 degrees Fahrenheit.
Sure.
But these were made. I think that the pot touched the polycarbonate.
Oh, it looks like that. Yeah.
I got this.
Yeah. Well, that raises the question. Then the surface of the pot can get.
The surface is hot.
Yeah.
And one time when I was finished, I was taking it apart, and I didn't realize that when the pot is removed, the sun was also hitting the bar.
Oh, sure.
And when I pick up the dish, I usually pick it up with a bar, and I got second-degree burns on here.
Ooh.
Yeah, it's kind of stupid of me to do that.
Usually we've all been there.
Usually I have gloves on, but I didn't.
Yeah.
Yeah, but it gets hot.
Yeah.
Yeah.
Okay. Well, thank you so much.
You're welcome.
It's beautiful, and of course, another tracker, just like your previous one. This one just it's set up from the shadow to know when it's in line.
Mm-hmm.
So you must set it to where it finds that line first, rather than just if you set it in the middle. If you just set it out there, it doesn't find it.
It'll
directions.
If I set it out where the little solar cell is fully exposed to the sun, it'll keep rotating. The motor will cause it to rotate. If you're looking down on it, it'll cause it to rotate clockwise. It'll rotate until the shadow starts to fall on the solar cell, and then when the shadow affects about 10% of the solar cell, the voltage drops and it stops.
Okay. So
Then the next time the sun will continue to move, and it shows more of the solar cell, and then it moves again.
Okay.
It doesn't go back and forth. It just turns and stops, turns and stops.
Sure. That sounds like the Al Nichols cooker, where he just has it going the one direction until exactly that.
Yeah, there's no reason for it to go back.
Yeah. Okay. Well, that's thorough, and like I say, anyone wanting to build a cooker, and especially with regards to having a parabolic shape, it's all here. And I hadn't thought of that. As of course, it only comes into play once you say you want to cover it as an oven. That you want to. Now you got to start thinking. You're going to insulate the back of it.
Making your own parabola is time-consuming, and you have to cut all your materials very accurate, and building it is difficult.
Yeah.
If you build it with pieces of metal or plastic, it's difficult and time-consuming, and it's hard to hold it together. And where this is, it's metal and sturdy and.
Yeah. I remember when I first bought the SK14, the big one, I bought an extra set of reflectors thinking someday I'll make my own, but I've never needed my own because I got so many other cookers. But I was glad to do that, so if I ever did build one, I already had one that was set, a set that was ready to go. Yeah. Okay. Well, thanks again.
You're welcome.
Yes.